Hey everybody, welcome back. Thanks for joining me once again in Unreal Engine 5. Today I have a new video for you about render targets and how you can use those to manipulate your materials for different interactions. Let me hop over to the engine and show you what I mean. I'm using render targets to manipulate my water surface. You can use yours for snow or landscape materials, footsteps, that sort of thing, but let me show you how I'm using them. I'll press play here. Watch as the ball hits the water, it creates a sort of ripple. It's a subtle effect. I've kind of made it subtle for the purpose of my game. But quite happy with how it looks. So let me try and explain how I did this, and then you can use my techniques for whatever you want in your own game. I'm going to pull this off so we can see it together. This is a rendered target. A rendered target is a texture that updates in real time, and that is useful for lots of different reasons. Let me show you what my rendered target looks like at runtime. It's just a black square, and then when I hit the water, I'm generating these white expanding and fading out circles. And that information is being sent to my water material, and I'm doing some math to it to tell it to make it look like this. So in a nutshell, that's what a render target is. It's updates at real time. I have my render target set to a size of 2048. It starts at 256 by 256. That's the resolution, and you might want to keep this maybe smaller, like 512 or something. 1024. I've got mine kind of big for a reason, but it's going to be your use case, up to your use case. My camera is really kind of wide. It's looking at a wide area because I want the ripples to persist a little bit, so I need this texture to kind of be a little bit a higher resolution. Just to explain real quick what I mean, I'm kind of looking at an area of 8192. And that number is going to be replicated somewhere else. But so just to explain why my resolution is so high, that's why. And I've also clamped the address XY. In order to create a render target, it's fairly simple. I want to make sure you can see here. I'll go over here. Just go to texture / render target, and then name it, open it up. You'll see kind of very basic options there. So what we can do with that, we're going to assign that to a scene capture component. It's like a camera. I'm going to go to my player and I'll show you how I have that set up. The relevant code is in red, so we'll look at that. I have a ripple watcher, I called it. We go to viewport. The ripple watcher is way up there. I set it at 1,000 units above the player just to avoid some clipping and stuff. Although it doesn't necessarily matter how high you have it, because we've changed the projection type from perspective to orthographic. So you imagine, oh, I moved the camera back, you can see more. It's not the case in this sense. We have it orthographically set, so it's just going to shoot down like a fixed width and see everything within that width. So I've got it matching 8192. It matches what I had in that parameter of my water material, and I'll explain that afterwards. But basically, I want this camera to kind of see a pretty wide view of my water surface, so that's why I have it set so high. And then if we scroll down, we can find the texture target, and we've assigned it my render target, RT ripples. So it's going to be looking at my scene capture. Sorry, it's going to be looking at that render target texture. And if I kind of go back to the event graph here, on tick. So in order to get that camera to follow my ball, it might not be the case for you. If you're using a character, like one of the default characters or something that doesn't rotate and spin, my ball rotates and spins. So I always have to keep that in mind with anything I attach to it, especially if I want that thing to kind of stay stationary. So what I had to do was I made it -90, so it's pointing down, and I turned the from relative to world rotation and for location. So its location is going to start at 0, 0, XY coordinate, and then 1,000 units above. 1,000 units above the origin of whatever map you're spawning it in. And then on tick, I'm telling it to follow my ball. I'm doing a few other things with tick, but here I happen to be sending, this is also relevant, we're telling our material via a material parameter collection where my ball is at any given time, so that I can use that right here to tell my material where that ripple should spawn. I tell it where the ball is, and that's where I want my ripple material effect, I guess, to spawn. Anyway, well, since I'm talking about it right now, let's do that real quick. If we were to come to my water folder, oh, maybe it's in my materials actually. Yeah, it's right here. NPC ripple data. It's a material parameter collection. If you go to materials, you can find a material parameter collection, create your own. I should have just called it master, but I called it ripple data because the only thing in there is one thing so far. It is a vector parameter, and I've called it ripple center. That's how you see it over here. And that's all you do with an NPC. You don't really, it's not complicated. It's just like kind of a struct or a list or something. So I'm going to feed my character's location into that variable, and then through my material, I'm going to take it and I'm going to do some math with it. Again, we'll come back to that later. Just kind of explaining how we're setting it up. Set camera to match. Yeah, so we're doing the same thing. We've got the player's location going to the material information, and now we're going to actually tell this ripple watcher to set its world location to where the ball is. Notice I'm not using the Z location because that would bring the camera right down to where the ball is, and then we're going to intersect with the water, and it's going to cause like this strobe flickering effect. So we don't want that. I'm going to keep it fixed at 1,000 units above the water. Even if my ball goes above it, doesn't matter. I only care when the ball hits the water. My water plane is always spawned at 0, 0, 0. It's always spawned at 0 Z axes. So I know I'm always going to be 1,000 units above the water. I'm going to see whenever that ball hits, for sure. So that's fine. So that sets up my camera to watch for my ball. Let's show one more setting you might have to change. Go primitive render mode. By default, I believe it's this one. I want it to use a show only list, so that I tell it exactly what I want it to watch for. It's not going to just record the whole scene. Like in some use cases, you might want it to record the whole scene, like a mirror. Say if you're setting up a mirror, you could use a render target and apply that texture to the mirror, that plane that you want it to become a mirror. And if your character walks in front, it looks like it's a mirror kind of thing. I only want my capture component to watch for something I tell it to. So that's how we set that up. And also while you're here, it's nice to have a very dark black background in your capture component. So you can go to show, scene capture. I've unticked a few things like fog, landscape. Maybe that one's not so important, but fog, cloud, anything to do with lighting, sky lighting, and lighting. All right. Once you do that, you should get an image that looks like this. Back to here. So I think that's everything to do with the setup of the ripple watcher, or your scene capture component 2D. Yep. So we have to spawn some things, or we have to kind of create some stuff for it to look at, right? So what I'm doing is got this other actor I created called a ripple sprite. If I go to viewport, you can see it's just a plain mesh, static mesh. I chose a plane. Over here you can see, and I've attached a particular material I made that looks like this. And I've scaled it up. And in my event graph, I've got a custom event that I'm calling from over here when, right here, when my ball interacts with my water surface on begin overlap and end overlap. So when it goes under the water and then when it comes back up again, I want this effect to happen. So I'm calling this custom event activate ripple from pool. So yeah, so we're calling this custom event on overlap. If I go back to my ripple sprite, I've got this custom event here. And what it's doing is using a timeline play from start. I've got the scale being adjusted and the opacity. We've got, here's the timeline. So they're kind of going backwards to each other. I've got this not quite set at 0. The size, the scale I mean, starts at 0.2 instead of 0, and it scales all the way up to 1. And then the fade goes from 1 to 0 over 1 second, which I might want to play with later, but for now it's okay. And it's trying to find this scalar parameter. So we're using dynamic materials. Notice I'm not, anyway, I'm going to get in the weeds about materials. I have a video idea coming up for just materials. So we'll talk more about dynamic material instances, but if I go and browse to this one, let's find that parameter called fade alpha. Here it is. Open up the master so you can see it. In order to create this material, I just used 2 sphere masks and subtracted them from each other, and then multiplied it by a parameter value called fade alpha so that I can just fade it out. I don't need to do this. Just close that. Okay. Where was I? So when this custom event is triggered, it's going to scale it up, it's going to fade it out, and then I'm going to set it to hidden. That's important because what I'm doing on begin play is I'm spawning 20 of these ripple sprites, and I'm setting them to be hidden in the game. And this is also, because with the system I had before, I was spawning and destroying every single ripple, which was a crazy idea. It's not good for the garbage collector. It's going to blow up someone's CPU. So I decided to create a pool of 20 actors. That's the pool size here, variable int. I've got it set to 20. Can't see that, but it is 20. And on a for loop, we're going to start at index 0, and I'm going to go up until my pool size -1, and we're going to loop through a bunch of these actions. So we're going to spawn a sprite called ripple sprite. We've looked at that. Doesn't matter where it spawns, but I do want it to ignore collisions, so I selected always spawn ignore collisions. Then we're going to set it to hidden immediately so that this scene capture camera here, ripple watcher, can't see it. And then we're going to set the owner of it to me, to the player, sorry, to the player ball. And that's cool because even when we set it to not be hidden, we, the player, don't want to see this thing. We just want it to affect our material. So if I set it for me to be the owner, and then I go to my actor and I say see owner no see. If I check this to be true, that means if I make myself the owner of that actor, I will not be able to see it when the game is running, even if I have this hidden toggle switched on. So this is good. Now my camera, when I switch it to be not hidden, my camera, my ripple watcher is going to be able to see it, but I won't be able to. Then we say we're going to add it to the list of things that this camera is looking for by doing this. Show only actor components. And right, we're feeding the output, the return value of the spawn actor. We're kind of just feeding all of these things here. And then finally, we're adding it to an array called ripple pool. So this is all in begin play, right? So as soon as the game starts, or this player is loaded into a level, it's going to spawn 20 actors and then just save them in reference, save them in memory. So then when I want to use them, I can call this event. Again, we'll go back to ripple sprite. It's going to, over this timeline, where do we show it to be not hidden, I wonder? It's got to be in this here. So let's go back to the ripple. One second. Right. Okay. It is right here. So I was kind of misleading earlier, misreading even. This is activate ripple from pool, which is a function on this player here. If I go switch to it, let's see what it does. It's going to get one of the ripple sprites from the array at pool index whatever is currently set, and I'm going to teleport it immediately to where my player is, my get actor location. Then we're going to set the actor as not hidden so that the camera can see it, but remember I won't be able to see it. And then we're going to call this function which exists on the ripple sprite, which is reset ripple. So that's going to trigger the scale up and fade out, and then eventually setting it back on the finished pin. It's going to set it back to being hidden. So we've pulled one out of the array, we've brought it back to us, we've made it visible, we've done the operation to scale it up, fade it out, and now we want to increment our pool index with this function. Is just an increment. It's called increment float, increment int. It's going to increment it 1 by n, then set it, and then we're going to use a modulo so that we roll over from 19. I've got pool size of 20, so it rolls over when it hits 19. It's going to go back to 0. And I was just using a debug to make sure that that was accurate. So that's how we handle spawning in the ripples. But in fact, we're not spawning them in. We're just showing them and hiding them. We've done the spawn in at begin play. And that's the kind of optimization part that makes sense, because like I said, I was spawning and destroying every time I needed a ripple, which is not good at all. Okay. So where from here? That's how we're triggering our interaction. This is how we're kind of setting ourselves up. We've got the camera set up to watch for it. Let's look at the water material now. So prior to when I had this set up, I was just using all this information, right? And it was going into normals. Now I've got, this one is distance field stuff. We'll ignore that for now. Let's just focus on this. So if we want to know where we are in the world, we're gonna, where to put our ripple, we need some UV coordinates. So this absolute world position node we use quite a bit for different things. We're going to subtract, we're going to mask out just the XY coordinates. We don't need the Z, which would have been in B here. So we're going to mask that out of my ripple centered data. And we're going to subtract these two. And using a capture width, we'll divide the result by that, and then add 0.5 so that we make sure we're centered. And then I've rotated mine. I don't think I needed to do that actually. Maybe take that out. This was early debugging. You probably don't need this. You'll find if you plug this straight into wherever this is going. This output could be your UV coordinate. So now you have some UVs. I made this after the fact, but it's been very useful. A box mask helped me fade out the ripples as they reach the edge of my camera's vision. If you don't do that, then the camera extends the last pixel data information off into like the distance. So you're going to see these weird artifacts of lines stretching out in the distance if you don't mask those out. So you can just kind of copy the information here. This is just to make the mask soft. This is an engine node available to everybody. Then this is a texture object which uses our render targets. It's different from a texture sample. You want to make sure, because this node only takes texture objects. So it's a normal from height map. What we're doing is we're creating normals from our texture ripple, which is going to be sent to this water material via our render target. So we did all that work prior. It was just to get information to that render target. Now we're using that information. And plugging these things in here, this is just, I'm multiplying our mask by an intensity parameter, and I'm going to plug that into our normal intensity, and then all of this is our UV math, right? So we're going to plug that into our coordinates. then, so what the output is, this is a normal. If you already have some things going on, like if you have ripples on your water surface, you're going to want to blend it with the output of that math. So blend angled corrected normals is the node you want. I'm using it twice because I ended up adding the distant field ripple foam thing. I'll show you later. And then just plug it into your normals. So, a lot of talking, but all of that setup we did here was just so that we can get good information on this this render target, and then that render target is what we use in our water material. And let's see that one more time, yeah? Just like that. You can see the numbers on the left hand side of the screen, going 18, 19, 0, 1, 2, 3. Those are our 20 sprites being hidden and then not hidden over and over again in a loop. So I'm not destroying any of those actors, I'm reusing them. That's what makes the system efficient. And you can create your images on your render target in a billion different ways. I've done this with Niagara particles and told my camera to look just for the Niagara particles, and then it generates a thing. And so there's so many ways you can use this render target to affect a material of your choice. So I'm affecting my water. You could affect your landscape. You could have a snow material, and then you could affect that. You can use the world offset position node here to actually deform the mesh. My mesh is just two giant triangles, so there's nothing to deform. But if you had a sufficiently dense mesh with enough triangles, enough vertices to displace in a smooth enough way, you can just plug all your math into this node here, this pin, and you get some really cool deformation. That would be really cool for your snow, for instance, if you had dense enough vertices in your snow. And those trails would last as long as your camera stays with your thing, and then they would fade out in the distance with your box mask. And how far that would work would depend on your capture width, which you should remember to always match it to your camera's ortho width over here. So I hope that was clear as mud. Let me just spend 2 seconds looking at this. This math is really easy. So, copy and paste it if you want. Foam width. This is how many ripples you want happening. And then you can play with the timing of those ripples here with this division number. I have it set up so that... let me just press play. So that my ball doesn't use distance field foam, but everything else does. So what you have to make sure you do is, if you have a surface that you want to use like water, see I'm making like little ripples over here, you have to turn off, find the mesh that the material's on and go distance field, and then uncheck where it says here, affect distance field lighting. So that's unchecked. But if I, select this one, there, allow distance field lighting is by default is true. So everything else has it by default is true. My player ball has that deselected here, as does, I guess, my follower ball does, and the water itself. If that isn't unchecked, it's not going to work. You have to turn the material that you want to have those effects on it. You have to uncheck distance field allow lighting. Okay. I really skimmed over that foam bit, but you're smart. You can figure it out. I showed you the math. I've made mine very subtle. I'm not sure I'm going to keep it in the game. Not sure how I like it, but yeah. And I'm going to play around with the intensity of these little splashes and the size of them. I can do the size, play with the size, just going by ripple spray here. This plane, I'm going to bring it back down to like say 4-ish. 4. Yeah, 4. And the timeline I have scales it from 0.2 of 4 up to 1. 2 times, eh? Interesting. Forgot I did that. Well, anyway, it's going to go from 20% of whatever the scale is all the way up to, I suppose I'm doubling it. So you can play with the size of your ripples by doing that. Yeah, I think that looks a little better actually. Cool, eh? It's just a little visual touch I wanted to add before I move on to making more levels. Yeah. That's all for today. If you have any questions about how I did this, maybe I skipped over something, maybe you're running into problems, leave a comment down below and I'll try to help you out, okay? Thank you so much for watching, and we'll see you next time. Cheers.